In a carnival, he is me. And she is right with the ribosome. Look, protein comes out of that. Also, younger children became ribosomes. And this is what happened to me by one of the best artists and writers in Israel, Michel Pishka. And if you have a look very carefully, this is the larger unit, and this is the small one, and it's symmetrical. And he thinks that the best place for antibiotics is here and here. Thank you. Okay, I hope that you liked it, and I hope that something will come out of it, at least mentally, intellectually. And as I said, I would have liked to be here with you today. Good day to all of you. Good day. I would have liked to be here today. And to have the legend was shared with us. And thank you, Dr. Ada, for putting all your efforts to record this video and send it to us. It is now time that we take you on a small tour to our university. So I request the virtual tour the details to be created.
मेरा कॉन्फ्रेंस स्ट्रीमिंग चल रहा है देखो मैं आज उठ नहीं सकता 2 दिन मैं स्ट्रीमिंग चल रहा है ये देखो इसलिए इतना तामझाम लगा के बैठा 3 डिवाइसेस से स्ट्रीम हो रहा है अरे मीत ने चालू नहीं किया फेसबुक लाइव लंच ब्रेक में 5 मिनट में
It takes a new form of education to prepare students for the society that is upcoming, and that's why the focus on innovation is critical, and that is the focus that the university has taken.
Ours is a special university, simply because we do not make mere professionals here. We make better human beings.
This university mainly focuses on value creation.
Everything is filled with lot more fun, and it just makes you filled with more optimism, and you have a lot of things to get inspired. You just feel like coming to college every day.
We ask the students to focus more on the imagination part of it, intuition part of it, rather than the historical facts and figures.
Explainable Patel University offers tremendous flexibility to the students in choosing the subjects they want to study. This is the key aspect when students can determine where life will be.
so that goes around 2,500-3,000 with insurance.
It is said that everyone do not have the same type. We have different fortes, we have different space of interest.
Explainable Patel University offers a future-focused standard and we follow these international standards with complete rigor, and we ensure that our syllabus is built around these international standards.
We believe that our students need to rub shoulders with talent across the globe.
In the times of globalization, unless we internationalize our education, this education will be incomplete.
One of the reasons why we have tie-ups with universities abroad is to help our students get the kind of opportunities, the kind of exposure that they require working in global environments.
They get that international understanding which is so very critical in this globalized world.
We focus on T-shaped professionals who are not only experts in their domain, but also know the importance of other skills to make them the winners of tomorrow.
A T-shaped professional is a professional where the vertical of the T depicts the depth of a discipline and the horizontal of the T is the breadth.
We try to imbibe these values with innovation, constantly ideating, changing, innovating.
We have a great platform by the name Innovation Factory where industry problems are brought in and students from multidisciplinary teams across different schools, depending on what is the nature of the problem that we are solving, come together under the guidance of a faculty and solve that problem. And that is what gives students the real life experience in the real sense and not just theoretically.
The best part is the campus itself, the greenery of the campus, the silence, the peace that the campus has.
It's very scenic. It's very pleasant feeling.
It's like all
Very
space,
paranormal.
nature, and it's colorful.
It's a different experience every morning when I enter it.
Quality of life for the student is great over here. The students are able to express themselves in so many different ways which otherwise would not have been possible for them.
This is one place that you have to be a part of sometime in your life.
And that's what is this university about, that it is the coolest university.
This is the coolest university.
It takes a new form of education to prepare students for the system.
At School of Engineering, we are working on a theme called as innovative engineering. We are giving enough freedom to the students to work on their ideas.
The course in this college is very innovative. It's not monotonous.
We have contacts with the industries, and as per their needs, we are molding the students, we are developing the students. We are given more practical knowledge instead of theory knowledge.
And hence we learn hands-on experience for all the projects and implementations of every logic that is taught to us.
We also have workshops which are partially entertaining and also helpful.
In our branch, we have different syllabus like not the basic code, mechanical or electronics.
We are taught every subject from every branch. Faculty that deliver you are very good.
All our faculty members are very supportive and we do not need to worry for the exams because our evaluation is based on different terms. So there is also interpersonal skills which are evaluated and co-curricular activities that have marks.
But we have a T-shaped learning where we give consent that we are not satisfied with our marks. So faculty take it positively and they show us some mistakes like we have done mistakes at this step. So we can improve, and that is why the faculty here is one of the best faculties I've ever experienced in my life.
The reason why we love coming to our college is because when we interact with the faculties, we can learn something from them, and they would have given us something back to us.
So we enjoy studying at every level.
This is the coolest university.
Well, we did see some glimpses of the coolest university that we have here. We are now waiting for the next keynote speaker to join us. So I request all of you all to be kind of patient for a few minutes. We are expecting him to join in another 4 to 5 minutes. Thank you. Life at 85U
It's very vibrant.
We've been given a little more freedom
Like you don't have to come to college in the morning and then sit through your lectures and get bored and then go back home. Getting to study like a lot of things in the first year and getting so much exposure has been so great because
We are not just very specific to our course, we are taught every subject from every
Teaching aspects are like more interesting because they hardly heard it in books. The practical sessions that they hold, it really helps us, gaining confidence.
We also have workshops which are like partially entertaining and also helpful and productive.
Workshops that we attend, they help us understand the gap between education and the industry and understand what we need to do other than gaining the technical knowledge.
the faculties at AWU are very chilled out.
I'm like very attached to this faculty because
They teach us to like be better humans and we are just vibing together like so nicely. It's like a family away from family. Examinations in ADYPU are really cool. You don't have to take pressure on what to study because 80% of the whole course is done in practicals and 20% is theoretical. During the exams, obviously the students are involved stressed, but the faculty here are really nice. So they tell you like if they feel stressed before the exam, they come and tell you that even they don't have to be worried about anything. And evaluation is based on different terms. So there is also interpersonal skills which are evaluated and co-curricular activities that have marks.
but we have a T-shaped learning where we give consent that we are not satisfied with our marks. So faculty take it positively and they show us some mistakes, like you have done mistakes at this step, so we can improve. And that is why the faculty here is one of the best faculties I've ever experienced in my life.
So that way your costing your during exams is really nice. If you're creative, 85P is the best place for you. You can have a lot of fun in the campus. We have a swimming pool, we have a tennis court, basketball court, volleyball court.
Football, cricket, badminton.
इससे पैसे तो कभी बने ही नहीं उसके बाद में there is अच्छा ना focus.
After I graduate from the ADYPU, I would most importantly miss all the hangouts for us.
मैंने direct किए थे और
I think I miss the most is the campus.
My friends, my faculty, and the food here at the university.
direction
The helping faculties and the workshop.
मैंने script में एक short survey ही दिया था.
It's really interesting to know all these guys from different parts of India. It's something that I will surely miss.
So there is this one agency known as Campus Times. We do very good stuff. तो उन्होंने किया था.
This is the coolest university.
इतने high-end equipment ही नहीं है अपने पास. And no one is trained to do so much work. मैं और अनुराग करें तो हम मर ही जाएंगे. That was a crew of 30 people for these videos. अनुराग, वो मेरे को कंटेनर का भेजना फोटो, वो डालना है मेरे को. हाँ, वो डालना है.
Ours is a special university simply because we do not make mere professionals here. We make better human beings.
So we ask the students to focus more on the imagination part of it, intuition part of it, rather than the facts and figures.
We are giving enough freedom to the students to work on their ideas.
Being a faculty here is very different simply because of the fact that we have the freedom to do what we want.
Within the realm of the curriculum, within the bounds of the curriculum, we are given a lot of freedom. Every effort is recognized, appreciated. It's always learning for a faculty as well.
I get exposure to research and the different presentations.
Work is not like work. Most of the times you're very involved, you're enjoying.
I call ADYPU as a happy university.
The theme, the mission, and the vision we are working for, this gives the driving force to us.
We have all the freedom to do whatever we wish in the interest.
Dear participants, thank you for your attention. We have our first keynote speaker, Mr. Jusung Hong, with us here today. Mr. Jusung Hong is a professor at the Department of Robotics Engineering, DGISC, South Korea. May we have Dr. Hong's introduction AV to be played, please?
Dr. Jason Hong is a professor at the Department of Robotics Engineering, DGISD, South Korea. Jason Hong received BS and MS degrees in electronics engineering from Kyungpo National University, South Korea, and the PhD degree in frontier science from the University of Tokyo, Japan in 2004. He worked as a foreign researcher of the Japan Society for the Promotion of Science with the Graduate School of Information Science and Technology, University of Tokyo. From 2005 to 2010, he worked as a research professor with Kyushu University, Fukuoka, Japan. Dr. Hong is currently a professor of Department of Robotics Engineering, DGIST, South Korea. His research interests include surgical navigation, surgical robotics, and augmented virtual reality. At the University of Tokyo, he has developed the first UI-guided needle insertion robot for a movable and deformable organ. While he worked at Kyushu University Hospital, he developed customized surgical navigation systems and clinically applied them to various surgeons. After moving to GIST, he studied medical augmented and virtual reality in collaboration with top hospitals of Korea. Aditya Devi Patil University welcomes you to ICISI 2025. Dr. Hong, once again, we welcome you to today's conference, and I now request you to kindly have your talk on image-guided surgery and medical augmented reality. Thank you.
Okay, can you hear me?
Yes, sir, we can hear you. Yes, sir, we can hear you.
And can you also see my presentation?
Yes, sir, we are able to see the presentation.
Okay. Okay, then let me start my lecture. Thank you very much for inviting me as a keynote speaker. So today I'm going to talk about image-guided surgery and medical augmented reality. So I think future surgery is aiming for accurate access to target and safe protection for the organs around target, and also minimally invasive risk for the patient to improve the quality of life. So to enable this future surgery, we need technology. So I think there are three kinds of technology to enable future surgery. One is advanced art. It means medical imaging and medical simulation and surgical navigation. That is my main topic of today's talk. And advanced hands technology is about robotic technology or instrumentation. And also recently we are very familiar with this big data, artificial intelligence, deep learning. These technologies also necessary, especially for the personalized medicine. So today, I want to focus on advanced eye technology. That means we can provide new vision for the surgeons where they can't see, especially inside the body, inside the organs. The native eye cannot see the tumors or blood vessels inside organs. But using this advanced eyes technology, we can provide surgeons with a new vision, new eyes that visualize the hidden anatomies in the organs inside body. So image guided surgery, that is the topic of my talk, is also called as surgical navigation. So using augmented or virtual reality technology, it displays position of surgical instruments like electrocautery, needle, or endoscope, relative to the surgical target, like tumor, blood vessel, nerve, on the medical images like CT or MRI. The surgical navigation helps the surgeon approach the surgical target accurately and safely while avoiding injury to the critical organs near the target. Later, it became mandatory to use in surgery in the United States. And in South Korea, my country, it starts to get covered by medical insurance. So today, I want to introduce this image-guided surgery for surgical navigation. So I think you are very familiar with this car navigation. So we display the car position on the map, referring to the signals of the satellite. Like car navigation, the surgical navigation displays the position of the surgical instruments. So this corresponds to the car, and on the medical images, we display the surgical instrument. Medical images corresponds to the map of the car navigation. And instead of satellite, we use this tracking sensor, position sensor that uses infrared sometimes, or then sometimes the position sensor uses electromagnetic sensor. But using this position sensor, we can display the target region. This movie is an example of the surgical navigation. I'm sure you can see this movie. So this surgery is for the pituitary tumor surgery. So through the nose, we insert endoscope and we insert instruments to remove the tumor. Here, the green means the tumor. This green object means tumor, and around the green object, there are two red bars. These two red bars represent the arteries around the tumor, and this green bar represents the surgical instrument. Using this system navigation, we can access the target, the tumor in green, while checking the safe distance to the arteries. Without hurting the arteries, we can safely access the tumor using the surgical navigation. So this is another example. So you can see the white area in the light part here, that is a tumor. So this surgery was performed in the MRI room. We took the MRI during the surgery. So usually we can only use this endoscope images for the surgery, but for this surgery, we use the surgical navigation. So we could check the tumor in green here, and there is also arteries near the tumor. So we should be very careful not to hurt the artery near the tumor. So using this surgical navigation, now the surgical instrument is very close to the artery. But using this navigation, we can avoid the damage to the artery. Finally, yeah, we remove the tumor in continuous surgery. This is another example. This example, oh, the movie doesn't play, so let me. Okay, so now the movie plays. In this surgery, we should take the brain tissue for the biopsy, for the examination of the brain tumor. But in this surgery, we should be careful not to hurt the brain neuron. So we displayed the brain neuron fibers like this in color. So we checked if there is no active neuron in the tumor, and we took the tissue, extract the tissue where the no neuron exists, the safe region. So for that purpose, we also use this navigation. So this surgical navigation is for the liver tumor ablation. So you can see this green tumor in the liver. So we insert the needle, and we using the microwave or using some chemical, we cure this tumor with needle. But in previous surgery, the surgeon can only use this two-dimensional ultrasound, as you see in the screen. This is two-dimensional ultrasound. It's very difficult to find the tumor. But using this surgical navigation, we can provide a 3D MRI, and we can display the tumor position, and also the needle position, and also the ultrasound probe position together, help to find the tumor position accurately. This is another example for the ear surgery. So for the people who cannot hear, we can insert an electrode to the cochlea to help them hear the sound. But when we insert the electrode to cochlea, the facial nerve is just in front of the cochlea, so we should not hurt this facial nerve displayed in lab. And surgical drill, using surgical drill, we access the target cochlea here, but we should keep distance, safe distance to the facial nerve. So using this surgical navigation, we can display the current surgical drill position, the target position, and the facial nerve we should protect together like this. So surgeons can do their surgery very safely. And this is for the disc hernia, intervertebral disc hernia. Using this kind of caster system, we can cure the intervertebral disc hernia. We use a laser, and we burn the disc area using the laser. But the problem is the use of X-ray to find the disc area. So radiation exposure is a big problem, especially for the surgeons. They have to do this surgery every day. So we developed this kind of surgical navigation and applied for the patient like this. So instead of taking the X-ray, we could display the target position, the hernia, this hernia position, and also we could display the caster position relative to the target. So without using the X-ray, we could access the target while checking the target position and while checking the current cast position. So using this system, we could reduce the radiation exposure of X-ray. And this is the dental application. These days, many people get the dental implant. Okay, but the problem is there is some nerve, mandible nerve, in the lower jaw, and in upper jaw there is also some mucous membrane to protect. So we developed this kind of navigation system to guide the dental implantation. So we applied that system for the patient. So in this case, the upper uh, uh, implant. So using this kind of a mouthpiece jig, we do the registration between patient and CT image. Then we could display the current drill position and the target pass, okay, the planned pass to insert implant. And we also could confirm the margin, the distance to the membrane we should protect for the maxilla area. And this case is for the mandible, the lower jaw. In this case, we should protect the mandible nerve displayed in lead like this, and we should make a pass straight in the lower jaw. So we need to check the drill position and the pass for the implant and the distance to the patient nerve. So we use the surgical elevation for this purpose. So from now on, I want to introduce the augmented reality. That is one of the major topic of my talk. So how can you use this augmented reality for this surgical navigation? We'll explain about that. So as you can see, the dolphin or the ocean and the icebergs are the virtual one, but the people are the real one. The augmented reality means there exists both the real object and virtual object together. Okay? So in this case, for the entertainment, people are enjoying the virtual ones, dolphin, icebergs, penguins. So this is for the entertainment. And but we use this technology. We can use this technology for the medical purpose. So for the augmented reality, as I said, we need a virtual object. Okay, virtual object, and yeah, we need a virtual object, and we also need a real object. Real object, and we also need the camera and display for the augmented reality. Camera and display. Camera is for the taking picture of the real object, and display is for the display of the real object and virtual object. And another important component is position sensor, because the real object is moving, and also the camera to take the real object is also moving. So we should follow, we should track the both position of the real object and the camera, and we need to calculate the relative position of camera to the real object. Then we can calculate the virtual object position and orientation, and using that information, we can make a successful augmented reality. So the left image is conventional virtual reality-based surgical navigation, as I just explained so far. So using this conventional surgical navigation, we can know the access direction to the target and we can know the safe distance to the important organs. But the problem is, uh, we should we should turn our eyes, the surgeon's eyes, to this navigation monitor to see the navigation information. But the surgeons want to concentrate on their patient. They want to continue to see the patient. They don't want to move their eyes, turn their eyes to another object. So we developed this augmented reality in the light images. You can see this image is the surgery scene. This is the surgical microscope images for the ear surgery, cochlear implant, ear surgery. But using the augmented reality, the important organs like facial nerve and the cochlea in green, we can overlay these important organs on the microscopic images. So the surgeons can continue to see the microscopic images. They can see the patient directly without turning their eyes to see the navigation information. But by overlaying this navigation information, they continue to concentrate on the patient, and during the surgery, they can refer to the navigation information. So we decided to use this augmented reality for those surgeries, especially using the surgical microscope or surgical endoscope, especially for the surgeries that require the camera system. Then we can make this augmented reality very effectively for those surgeries. So we have this relationship. The real object for the surgery means the patient or the instrument, and virtual object for the surgery means the tumor, vessels, or nerves. They are not actually virtual; they are real ones, but we can explain using this comparison. And camera display, if we have the surgical microscope or surgical endoscope, we already have the camera system. And position sensor, we sometimes use the optical tracking system, OTS, or magnetic position sensor. But the camera itself can also be this position sensor. So sometimes without these OTS or EM sensors, the dedicated sensor system, we can use this camera to replace them. Of course, the accuracy is compromised. And using these resources, we can calculate the virtual object, the tumor position or vessel position, and we can display them on the camera image, endoscopic images. So I want to skip this part for the time is limited. So this is the augmented reality navigation. So on the camera images, we can display the inner organs overlay on the camera images. So we can see the hidden organs. Originally, they are hidden, or they are invisible by native eyes. But using the augmented reality, we can display the organs inside inside organs. Or we can display the region of interest. And sometimes we can switch to this VR mode to magnify or to check the relative distance between them. We can also switch back to this VR mode. This is a real example of the surgery. So we use this tablet PC to display the tumor. So you can see this is a pelvic tumor surgery. So in green, we display the tumor position. So during the surgery, using this kind of tablet PC, you can make this augmented reality. It's very cost effective, okay, very low cost. This is another example for the tumor surgery in tibia bone, in leg, okay. There was a tumor. So originally, we should take a lot of X-ray to find the tumor position. But using this augmented reality, without X-ray, we can specify the tumor position. We can draw the marginal line, and we can cut the tumor area using this thing. And this is another example for the collective jaw surgery. So we can check the jaw position after cutting the jawbone as we planned. Okay, as we planned, we can check the jaw position during the surgery. This is another example for augmented reality. So the cardiovascular interventions, there is some occlusion area, some block region. Okay, so we should penetrate the block region. But using the X-ray, it is two-dimensional. It's difficult to find the 3D position of the block region. But using this augmented reality, we can provide the 3D information. Yeah. So also using the augmented reality, we can expand the narrow camera image, endoscopic images. So as you can see, this is the endoscope for the shoulder, but the camera field of view is very small, narrow. But using the augmented reality, we can display the outside of the field of view. In this case, the instrument position. Instrument position we can display, and if necessary, we can display the other organs outside of endoscopic view. So I want to skip this part. We can display the augmented reality for the Da Vinci surgical robot. This is actually the example of Da Vinci surgical robot, but I want to skip this part. We can display the tumor area or vessel area with the Da Vinci system. So lastly, I think we don't have enough time. So this is last one. So the bone fracture reduction. When you have the broken arms, broken legs, we need to connect to broken arms. But the problem is we should use a lot of X-ray radiation. And another problem is it's difficult to align the broken bones correctly, especially in Z-axis. A longitudinal axis, it's difficult to align the rotation by only using the two-dimensional X-ray. So we developed this robot system, and we also developed this surgical navigation. This is not augmented reality, but we display these two broken bones, and we can display the distance between them and the angle between them, especially the R means the rotation. It's very important information. So yeah, I want to skip this part. This is the developed surgical navigation. So you can see this movie. In 3D space, we can display the broken two bones, and we can connect this bone, align these two bones. So especially note that this axial image, the lower left axial images. So we can align the rotation using these images, referring these images. Otherwise, if we use X-ray, we have a lot of radiation. And a lot of radiation is a problem. But in addition to that, X-ray only provides this spatial and tonal view. So the rotation angle in axial view is very difficult to align. But using this navigation, we can align the rotational angle, and this is most important angle for the patient. Okay, so this is movie shows the total system. The user can operate this controller watching the navigation window, and the remote side. The robot can connect the broken bones. Yeah, we performed the animal experiment with both legs, but I want to skip this part. So let me conclude my talk. I introduced the image-guided surgery, okay, to provide the new vision, new eyes for the surgeon to perform the surgery more accurately and more safely. So using this kind of augmented reality or this kind of surgical navigation, we can visualize the invisible surgical targets in the organs, in the body. Augmented reality is usually more applicable to the endoscopic or microscopic surgery. The surgeries then use endoscope or microscope because the endoscope and microscope are the camera system. So on that camera images, on that endoscope or microscope images, we can display the augmented reality information. And we can also make this augmented reality using the portable device, like smartphone you have, okay? So without any additional cost, we can make this system for the patient and surgeons. Of course, if we need higher accuracy, we need the position sensor, special position sensor, like using infrared or electromagnetic wave. But if we compromise the accuracy, then we can implement this augmented reality with just a tablet PC. But we have still some problems. The accuracy depends on the registration. So today I skipped this part because it is quite mathematical theory, so it's better to explain later if we have enough time. So for the accuracy, we need to perform the reliable accuracy. If you want to know more about this, you can see my papers. You can search my papers with my name, then you can hit several papers about this. And also for the augmented reality, we need accurate camera calibration. It's also important. So those are the technical problems, and those are the topics of the research or study. And if we use the position sensor, we have to solve some blocking problems. If we use the optical position sensor, then we should solve this blocking in the optical lane. While electromagnetic sensor also have some problem caused by the metallic element. And in some cases, the markers we should attach it for the patient, or we should attach it for the cameras or such instrument. We should attach the markers, but those markers sometimes can be large, too large, or it's quite difficult to attach stably. So we should solve those problems. Okay, that's all for my talk. Thank you for your listening.
Thank you, Dr. Hong, for this insightful talk. I'm sure all our participants and live viewers and budding researchers and the other guests are also quite interested now in the image-guided surgery and medically augmented reality. And many would be inspired to go to know and read more about it. Thank you so much for this talk.
Thank you.
Our second keynote speaker for the day, Dr. Anand Nayar, is also here with us. Dr. Nayar is the Faculty of Information Technology at Duquesne University, Da Nang, Vietnam. May we have the AV played from his introduction tape, please? Dr. Anand Nayar has received his PhD in computer science from Desh Bhagat University in 2017 in the area of wireless sensor networks and swarm intelligence. He's currently working in graduate school as a faculty of information technology, Dutan University, Da Nang, Vietnam. Dr. Nayar is a certified professional with 75 plus professional certificates from Cisco, Microsoft, Oracle, Google, Bing Cert, EXIM, GAQM, CyberROM, and many more. To add further, he has published 100 plus research papers in various national and international journals with high impact factor. Furthermore, Dr. Nayar has published 50 plus papers in international conferences indexed with Springer, IEEE, Explore, and ACL Digital Library. Dr. Anand is a member of 50 plus associations as senior member and life member, which includes but is not limited to IEEE and ACL. In addition to this, he has also authored, co-authored, edited 30 plus books of computer science. He has been associated with more than 500 plus international conferences on the program committee as chair, as advisory board, and as a review board member. Dr. Anand Nayar has 10 Australian patents and 1 Indian design to his credit in the area of wireless communications, artificial intelligence, IoT, and image processing. He is currently working in the area of wireless sensor networks, IoT, swarm intelligence, cloud computing, artificial intelligence, drones, blockchain, cybersecurity, network simulation, and wireless communications. He is a recipient of 30 plus awards in the area of teaching and research, namely Young Scientists, Best Scientists, Young Researchers Award, Outstanding Researcher Award, Excellence in Teaching, and many more. He is currently acting as Associate Editor of Wireless Networks, Springer, Computer Communications, Elsewhere, IET Quantum Communications, IET Wireless Sensor Systems, IET Networks, IGDST, IGISP, and IJCINI. He is acting as Editor-in-Chief of the IGI Global USA Journal titled International Journal of Smart Vehicles and Smart Transportation.
Aditya D.Y. Patil University welcomes you to ICISI 2000.
Thank you for the video. Dr. Nayar, we are truly privileged to have you here today. And we now welcome you to give your talk on future transportation system, Internet of Vehicles, IoV.
Sure.
Over to you.
Can you see the screen, ma'am?
Yes, sir. The screen is visible.
Thank you. So, good morning, ladies and gentlemen. I'm Dr. Anand Nayar, and I'm working as professor and computer scientist in graduate school, Dutan University, Da Nang, Vietnam. So, it's a real privilege to be the part of this great academic institution as keynote speaker and session chair. So, the topic of the conference is very relevant these days, that what we can do in terms of innovative technologies and in terms of future-driven technologies. Ladies and gentlemen, imagine a future where you don't have to drive the car. Imagine a future when if you want to become a pilot in one time and you are not a pilot today, you can fly a car without having even a driving license, or a pilot driving license, I can say. Imagine that a drone will come and deliver the parcels to you. Imagine when we have the flying hospitals and flying taxis. Imagine the future that is going to change not only the revolution, but is going to change the vision of mankind, that how we act as a transportation. And of course, we have a vision for the eye, that how we can have the futuristic, smart, intelligent transportation system. Ladies and gentlemen, Internet of Things and Internet of Everything is doing a massive work in terms of technological disruptions. Now it is a time that we should discuss more advancements, that how these technologies can derive more advanced technologies and to which pitch we can take them in the near future. Internet of Vehicles is one of the areas that requires a consistent you can say, level of research, and even lots of IT companies and transportation companies, robotic companies now are working together with tons of car manufacturing and automobile companies to make these things possible. Volvo, Hyundai, even the biggest companies like Audi, Mercedes, they are all towards bringing this revolution, and the future is not very far. So, ladies and gentlemen, in this talk, I will be discussing about Internet of Vehicles, that is IOV, and futuristic smart intelligent transportation system. So let's welcome the future and let's see what is it and what the new standards that we can see. And all of you, please sit back, relax, and enjoy the lecture. And I will be taking some of your questions at the end of the lecture. So the agenda for the lecture will be an introduction to Internet of Things, the future infrastructure for the Internet of Things, because today, if you really want to derive IoT to the real time, we need to understand the infrastructure. Because as we all know that we are today working in 2021 and we are working towards 5G. And 5G will not be possible unless or until we don't change the city-based infrastructure. So in order to become a smart city, you need to plan many things. So in the same way, if you want autonomous vehicles, flying vehicles to come into your life, you have to change the infrastructure to a great possible extent. And after that, we will be discussing about the connected vehicle and intelligent transportation. And of course, I will be discussing enabling technologies, followed by conclusion. And if the time will be there, I will be discussing something with regard to security in the futuristic IOV, which is regarded as one of the most prominent areas to perform research and publish the research publications. So let's start with an introduction to the Internet of Things. So what is Internet of Things, everybody? So you can say that it is called the physical devices being connected to the Internet so that they can be accessed anywhere and everywhere, and they can give us a complete, smart and connected solution. But now I would like to take something to the new level. When IoT is not IoT, IoT is leading to the new future with more convergence of technologies, which is actually playing a crucial role as a foundation role for making the Internet of Vehicles, the drone, and even sustainable agriculture, and of course, smart buildings and smart cities as a possible viewpoint. Ladies and gentlemen, today in 2021, let us forget about Internet of Things. Let us start with the concept of Internet of Everything. And believe me, it is going to change the world into a more better way. And of course, this requires tons of investments by top corporates. And even we expect that by 2022, the investment can even lead to 14.4 trillion US dollars. So you can say that in terms of IoT, we just connect with sensors, we have some wireless communication standards, and we are getting some mobile apps and desktop apps to get the data, and we are adding up everything to the cloud. But now with Internet of Everything, we need to convert with more advanced technologies like machine-to-machine interaction, cyber physical systems, intelligent systems, connected devices, and of course, industrial internet. So remember everybody, whatever you think everywhere, like even blockchain technologies, or even what we talk of sensor communications, when you even talk of Skynet, everything becomes a part of Internet of Everything. So you can say that today, Internet of Everything is going to lead the future. And of course, every driven technology, every converged technology will be a part and parcel and derivation from this side. So Internet of Things or everything, you can see it's a convergent evolution of mobile and IT networks. We can see that with the evolution of IT networks, we started with millions of PCs and laptops that are even evolved to billions of IT devices in office and homes. And now you can see from the right-hand side the evolution of mobile networks. When we just started with pagers, we have our 1G communication, just a GSM call, CDMA. Then we go towards LTE, VoLTE. Now we have 4G, 4G plus, then 5G and 5G plus, and even 6G is being researched by Nokia and even Huawei. So you can say that billions of mobile phone voices, internet, SMS, and of course the mobile internet broadband is leading one way that is called from RFID to smart sensors to machines and to even more complex objects, for example, a driving vehicle. So remember everybody that even your vehicle will consist of tons of computers, tons of artificial intelligence algorithms, tons of sensors, and of course it will be connected to, you can say, your mobile infrastructure in order to make your transportation possible from source to destination. So believe me, a car is not going to be a very simple infrastructure, it is going to be a complete autonomous control system in itself. So the most important thing is that if you drive any your agriculture farm or even your car, it is actually becoming a new computer that is known as an IoT computer. Because why? Because it is getting the data from sensors, it is using AI, and we are putting the data in motion. And of course, we need the backend with the high-speed cloud networks, which is going to support for real-time automations and of course taking the decisions. And even with the new level of artificial intelligence called explainable artificial intelligence, you can even talk to the car that you talk, like today you talk to the driver. So you can say that from level 0 to level 3 and from level 3 to level 5 will be possible in next 4 to 5 years with Internet of Vehicles. And that is what we have to do our research, that how we can add new things to this and how we can add something towards AI. We have to work towards blockchain as a security mechanism. You have to work towards radars and lidars, and of course towards object recognition with advanced computational intelligence. So even a car consists of tons of areas for you to do your work, to do your research, and to give some implementations. So you can say that IoV is giving us a broad set of applications, and even the Internet of Everything is giving us a broad, massive scale of applications that you can derive. Like we talk of Internet of Energy, Internet of Agriculture, smart homes, enhanced safety, transportation, healthcare, smart city, buildings, and of course, defense. Now, even we are working on the area with the Internet of battlefield things. Even we are working not towards the Internet of medical things, but with smart hospitals things. So you can say that IoT is giving us a massive opportunities that what we can think of and what massive reference architectures with real-time applications we can switch on so that we can derive solutions and make everything connected. And of course, we have the leading options to solve the particular problems and to see the massive growth that how we interact with the machines. And with artificial intelligence, the life will become smoother and easier. So now we will discuss about the future infrastructure of Internet of Things. And believe me, everybody, that if you really want to talk of IoT or really smart homes, the infrastructure is not going to be easy. It is a complex infrastructure with tons of massive scale of connectivity, sensors, and of course we need application layer, of course we need the sensors, actuators, we need cloud computing, we need fog computing, edge intelligence, and big data analytics. So this type of fusion of technologies that we require, and as a computer scientist, I'm saying you that my work is to add more technologies to this convergence so that we can plan more and more modules and see the relativity towards how the things respond with the technology integration. So as a researcher, what I'm doing is that I'm actually an integrator of technologies and reference architectures, and we try to derive that how solutions can come up in the real time. So you can say that the common IoT architecture will look massive like this. You can say that in the physical layer or the bottom layer, we have the embedded systems and sensors, which are like called vehicles, wireless or wireless, wired or wireless sensors. Then we have the multi-edge services, which comprise of your connectivity, like a field area gateway, because the cars need to be connected to each other, like in the real-time advanced vehicular ad hoc network, or we can say V2X. And of course, we have the core, which means the special types of routers and switches. And even these days, Cisco is providing lots of portfolio-based devices that can connect from the tons of classes. And of course, they can have the massive connectivity support of sensors, and they can bridge up solutions to complex systems. And last but not the least, we have the data center hosting with cloud, which is known as a centralized intelligence known as cloud computing. So you can see over here that the endpoint intelligence, we go to distributed intelligence. And of course, I've told you that if you're driving a car, your data is not at rest, your data is in motion. So the car is there, so it has to go for the live traffic feed of the traffic, of the weather conditions, of the next road conditions. So all these sensors and all the devices have to work in real time, and they have to make the decisions in matter of nanoseconds. Otherwise, there will be a problem with safety and privacy of data. So we can have the distributed intelligence with cloud and fog computing emergence. And last but not the least, we will have the centralized intelligence. So you can say that these points of intelligence, that is called the end-to-end intelligence reference architecture, is going to play a crucial role that how the IoV will lay the foundation and how in the real time the Internet of Vehicles or autonomous vehicles will be possible. So you can say that in terms of applications, you can see that in terms of storage, ingestion, analysis, and in-depth analysis towards applications. So another example of IoT computer, you can see the streamlined parking, which is again an important area that you can see the cars. Now, the most important area that you can see that we need to derive in next 1 or 2 years is explainable artificial intelligence. So what is explainable AI? So today, if you talk of your machine learning, what you do, you just give the input, you just give some output and let the machines control and learn with the system model. And then you produce some data, you give some experimentation, you retrain the model with some programming and make the machines better and better. But the answers are only with numbers or statistical analysis. So in the near future, what we want to add, we will take the same machine learning models and data sets, but we will add some explainable AI algorithms and models so that if the data is coming, the data should be actually explained by the machine that why it is thinking that what is like this. So that become more useful and make sense in order to predict and make some decisions. So computational intelligence will have a meaning to the answers. So you can see over here that we start from the bottom line again with embedded systems and sensors on the road and even on the parking systems. So imagine if I'm driving a car and I leave to the parking, so the parking system and camera is actually talking to me that take your car to the straight, go down and take the left, and you will find the third parking waiting for you, considering the size of your car, and we will be giving you the automatic surveillance. So which means that the parking system, what it is, will be analyzed and will immediately give the recommendations to me. So this is called an intelligent solution for autonomous revolution that you can see in smart cities in the near future. So we have the distributed intelligence with fog computing, and of course with core, we are connecting everything to the standards of routers and switches. And of course, we have the network management and applications. So in terms of network management and applications, the SDN or NFV will play a crucial role. So now we will talk about intelligent transportation and connected vehicle. And believe me, everybody, that the future is not very far. We already started about 6 years back from level 0, and now we are at level 3. And the research is strongly moving towards in correct direction in level 4, and maybe in level 5, that is a complete autonomous revolution. You just have to open the door of the car and you just have to sit and just say, hey car, just take me to this place, and the car autonomously takes a decision for you. And even in between the roads, the car is actually talking to you that are you interested to go there? Are you interested to, you can say, for this type of discounts and other things, which means the car actually senses everything with object resolution, with the object detection and recognition, and give us a recommendations that what can be done. So you can add more and more features, but in the near future, we can say that once the level 5 automation is reached, we can move up to level 6 automation, which I think so is going to be a complete revolution, that how the smart connected vehicles can even talk to each other and maintain the lanes, maintain the security and privacy. So this is one of the example that you can see in front of you is called intelligent transportation. And actually it is the way that how we will live in a smart and connected city, or you can say a sustainable city with a sustainable computing infrastructure. So you can say we have the satellite communications and television broadcast. And of course, you will be happy to know that with the Elon Musk Starlink, which is going to provide the connectivity to unknown Earth locations, so that more and more population can be connected to the internet. We can even bring that revolution to the roads where connectivity is somewhat limited, especially when we see the places called India. When we go inside the rural areas, the connectivity becomes very less. Or you can say we experience a lot of latency and throughput issues in terms of communications. So at that time, communications cannot be broken off, because for the car, communication should be perfect. So Starlink can lay the foundation that how we can drive the connected vehicles in the city. And of course, we have the vehicle-to-vehicle communication with the form of connected sensors. And we have the V2X, which means vehicle to anything, passenger information, intermodal communication. And of course, we can even detect the roads and signs, and we behave like we are acting as a real-time driver, but there is no driver on the car. So IoT key verticals, you can see that the car with V2V communication will be using IEEE 802.11p standard. And of course, we will move up to the infrastructure field, which consists of your DSRC roadsides, mobile Wi-Fi's, consumer network, and of course electric charging network stations, which is right now you have seen in electric vehicles. But after the electric vehicles, the first important revolution will be the level 4 automation, in which the car will take most of the control and the driver will be of in level 5. We can say that there will be no controls for human beings. Car will make the decisions automatically. So all this will be communicated with some high-end operations, artificial intelligence in real environments, and of course all the data will be highly connected to us. So if you are really interested into the research, you can even design your own infrastructure or reference architecture for vehicular flight that can support almost end-to-end low-grade communication connectivity for the cars. And of course, everybody, you can see that the most important standard is not that is the research area is not your cars, because cars are already being manufactured. The most important area is to add artificial intelligence and to solve the problems of connectivity so that the cars can enjoy communication and they can work in a low latency or high throughput environment, which is right now not available. So the connected vehicle revolution will be able to provide us lots of revolution in terms of diverse applications of real time, with which you can see that the car will be able to communicate with audio, video, telematics, diagnosis, ABPS. And of course, we need the cars to be connected like we fly the drones today. The drones are connected to the GPS satellites. But for the GPS and for other things, the cars are not enough. We need something more. So I think so the Starlink network by SpaceX is going to be the revolution and the game changer for us. So this is called vehicle internals, and it is able to a swarm of sensors that are being connected here and there in the car. So you can say a road condition sensor, magnetic sensor, radar, rear views, front views, electronic car steering, hands-free system, GPS sensor, airbags, electronic control braking system, steering angle systems, and of course we have you can say road to vehicle and vehicle to vehicle communication based infrastructure of communication protocols. So all these sensors work diversity, and of course every sensor needs to be addressed with the 5G towers and 6G towers, and of course we need to have some massive scale of connectivity, because on an average you will be trying to note that on an average in 1 minute about 22 to 24 gigabytes of data will be downloaded by the car in order to move in that right now. So it is not like getting the Google Maps and other things. The radar, and other sensors have to work in real time. So that's the reason, everybody, that no doubt cars are there, technology is there, but infrastructure becomes a big problem when it comes to connectivity. So this is the traditional ECU the topology that you can see with unsecured access and network security being a strong ECU. But now we are replacing it with the advanced technologies like smart high intrusion prevention system, and of course we are replacing it with blockchain. So right now, if you ask yourself, can you do research into IoT? Yes, you can do a full research in IoT, but right now we require more people for researching towards blockchain orientations, that how we can connect blockchain towards digital cloud security and towards in-house security of the car, so that there is no room for any hand to man in middle rack or outsider threats to the car, because every sensor of the car has to be connected to the internet. So this is the integrated future vehicle network that is called ISVN, and even I'm happy to inform you that I recently got one paper in ICISI transactions on intelligent transportation system 7.8 impact factor, and now we have even delivered a solution that how we can make our own integrated future vehicle network. You can see that paper, and even we just published this month only on July 7 one paper in FECS again 7.6 impact factor, that how we can make security into vehicle. So you can see these two papers into high impact applications. So you can see that over here that we have the new features of integration, Ethernet-based central vehicle gateway, and of course possible reduction in harness speed and bus. So this is what we have to work, and with the power of smartphones and smart connectivity, like with the advanced Wi-Fi 6. And of course, in the near time, we don't expect the Wi-Fi 6 also. We expect that connectivity could be around LoRaWAN, and of course, we need to activate internet-based connection when we using RSA software. So this is the ECU configuration and documentation with advanced documents. And this is with how we actually link to the data center with virtualized ECUs. So right now we are doing the research on vehicular
the clouds and even towards local ECUs, and even I'm also designing my own software domain networking for network-based
So
systems
even if you have
for
one
connectivity.
foreign speaker, that becomes an international conference.
So now we will be discussing some of the enabling technologies that is actually going to be required that if you really want to make the car to work for you. So you can say a few enabling technologies are security, for computing, seamless connectivity, mobility, and of course NIST. And of course we need the ad hoc networking for mobility and we require a deterministic network. But in the near future we can say that the real data networking NDN would be a strong solution for these connected networks. So let's talk of security, everybody. So you can see that when the car is there, so right now the most important is that the car needs to be prevented from all type of intrusive threats. And of course, internet is unsecure and car is getting the data and transmitting some data. So it is not possible for us to make a secure VPN gateway from the car to the cloud. It is impossible. So what we have decided is that we can have the onboard firewalls, and of course with these onboard firewalls we can have the end-to-end security towards intrusion prevention, antiviruses, and of course we have the simplest identity and policy management. But of course, considering the new type of threats, even we have observed some threats that are coming, that even hackers are locking the cars with ransomware attacks. So for these type of attacks, in order to prevent them and to have a peace of mind, we can only trust the blockchain technology. So you can say that of course we have the VPN applications, but VPN is not practically possible for all sorts of tools and weather situations. So fog computing, of course, very important, everybody. There was a time when fog computing was not taken as a very serious technology, but nowadays fog computing is actually required when we talk of real-time artificial intelligence. And with Explainable, fog computing is the only solution that can deliver the promising results and real-time critical solutions to the problem. So you can see that fog computing is basically known as a systematic, highly virtualized, secure, and network-integrated computing with storage enabled from endpoint to endpoints. And that's the reason, everybody, that if you are talking of tons of the data that is in motion, we can only trust the fog nodes. And these fog nodes can have the relative connectivity with the cloud computing. So if you really want that the car should move in the right direction, they can have the right information to be downloaded every second, and strong connectivity with the satellites. So every car will be like a fog node that is moving in the city and having a relative connectivity to 5G plus or 6G and having centralized connectivity to the hybrid clouds. So this is one of the use cases that you can see with fog-based scalable video streaming. So at the front you can see there is a car and it is connected remotely as a fog node to the fog server. And it is the biggest IT network which consists of tons of edge computing devices supported from Cisco in terms of gateways, routers, and switches. And in the end, we have the web servers where the data is stored. So you can see over here that from here to here, they require end-to-end connectivity. And if the car is moving to urban to rural or rural to urban or to some remote locations, this type of connectivity is not possible with VPN. So that's the reason that you need to have some onboard security and of course fog computing based training services. So this is called the roadside computing, where you can see that it is based on convergence of routing, computing, and wireless technology with a multi-tenancy computing model and located with traffic control equipments. And the purpose is to regulate the traffic, collect the toll, e-commerce support, content delivery, and of course we have the traffic sensors. And believe me, everybody, that when I'm doing my research, even I'm designing my own autonomous vehicle, and we are doing strong research with some researchers with Korea. And believe me, every challenge that we have observed in the last 3 years, it has been solved. It has been solved. It is, I don't say that it is not solved there, but the problem is that still those solutions can work in real time and are the relatively good of the results that can make this car possibly to see the sunrise in our daily lives. We can say that still we need to work. So if you ask me that are we ready to buy an autonomous vehicle, then we should buy some like a level 4. I say that still it is a time that we should hold on, and still because electric vehicles are still struggling, and of course we have seen that the people are still buying the petrol cars. So it's a time that we need to build up more of the infrastructure. We have to have more research towards cloud computing and of course with real-time applications. And then this will be possible maximum by 2028 onwards. But right now, if you ask me, we are not so much ready because as a researcher, I'm telling you, you know the problem, you know the solution. Sometimes
sometimes the model is perfectly working, but if we change something, the entire model gets spoiled. So it's not an easy research. It's called a very complex research where solutions are there, but still we need to be very sure that the solutions are actually 100%. So for that we need more. So seamless and optimized connectivity and mobility, this is the most strong area which is requiring lots of research, and of course with city planning. When we talk of cars, we can't trust 3G or 4G. They are very limited. They have huge latency in sort of problem, and we have this problem with seamless connectivity. And if there is a problem with connectivity, the car can even strike the nerve. So that's the reason, everybody, that we have to wait for 5G plus and even for 6G. And that's the reason there are some things that people ask me that, sir, when India will be ready for connected cars or flying cars. I say, just first of all, don't be ready for the cars. Just first of all, try to build up the nation or build up the infrastructure that can be ready for that cars. Because right now, the cars are there or technology is there, but are we ready for them? It's not. So you can see over here that we have to have the seamless optimized connectivity, and we are talking of 5G plus with mobile IPv6, single IP reachability, and of course the most important thing you can see, which is not available in India, even if you talk of Jio, Airtel, or any other mobile service provider, that is 99.99% reliable connection. Is your phone in 99%? No, just getting a rail and the connectivity stalls. And of course, we go inside, sometimes we don't even hear our voices on WhatsApp. So we need to have the flow-based connectivity, and of course, there is a lots of room to build up new standards so that we can have the proper city planning with the connectionless routers, and of course, with the in the future standards like 802.11 AE, and of course, AG standards are also coming up, and still we need to work on that. So this is one of the mixed mobility architecture that you can see, but still this architecture was level 3 based automation, but still we are not in confidence that this architecture can lay the foundation for the future. Because still we got some RTOs, we have some issues with regard to Wi-Fi coverage. So we need to plan more advanced area with 6G. And this is the cloud to fog application domain when we go for the farm. So we need to have the updated geolocations, IP networks, and of course sometimes with systems and pop control. Ladies and gentlemen, sometimes I ask my friends in India, are you using AirTags? They say that yes, we are using AirTags, but sometimes we are not able to find the AirTag because of non-seamless connectivity. So imagine if today we are having connectivity with just calling in on WhatsApp or other things. So this type of infrastructure is not applicable for the cars. They require a very important infrastructure which is having seamless connectivity with the exact 99% data part and control part, which is not possible. So this is the ad hoc networking. So we can have that in terms of evolving and deploying new networking paradigms. We need to understand more towards the delay tolerance, large set of real-time applications, high mobility exchange, and of course we need to have very less high loss situations. So disruption tolerance is required. And DSRC is a key component for digital technology, which you can see that with eCall and DSRC, we can have the more broader CD deployment, and of course the latency critical vehicle to vehicle and vehicle to infrastructure communications. So this is one of the multi-hop communication network architecture that you can see that the cars are moving up, and we are moving at a speed of about 45 to 50 kilometers, and the towers are being controlled at not with the, that is called your 4G or 5G, which is with the IEEE 802.11p standard, and at the back end we have the internet with fixed infrastructure. So imagine everybody that we need to plan massive in terms of connectivity and of course security, because if a hacker can hack your car, he or she can be a huge respectable person for doing lots of disaster in the daily life. So this is what we can say of collaborative ad hoc network, where we have computers, mobile devices, mobile sensor nodes, and of course they are connected with UAVs, unmanned aircraft, and of course we have the gateways and
गाइस तुम लोग को अगर वड़ा पाव खाना है तो मैं जाके ला सकता हूँ 4 बजे अन्ना वड़ा पाव क्या बोलते हैं
disaster response network. And even I'm happy to inform you, recently we have done our Indian patent, and now we're going towards the US patent also with LoRa communication. And I'm the first professor in the world who has made the LoRa possible for agriculture and even possible for smart city-based connected network. And now we are doing our research for high-end ingredients and
मिर्ची
delicacies
कांदा सब
that is
चटनी सब कुछ
that is
देता है
you know,
देवांशी नहीं खाई
used to
शुरू
make the
बहुत
independent
खाते
brain
हैं
sensor network possible as soon as possible. Like if you know the deepest
इधर भी है
possible,
बाहर
the
है
underwater
जगत
science
में
can
के
be
पे
possible. You can have a massive scale of connectivity
हाँ
with sensors.
या ना चाहिए
And last but not the least, that is called the deterministic communication, which is having the key elements towards network ingression, network synchronization, timely transportation, and of course, in terms of wireless, we have 802.15.4 for low power, low rates over Wi-Fi, and for high data rate, that is 100 watts. And this is the future evolution of Internet, Ethernet, everybody. You can see that we have started from unmanned, we have gone with managed, that is wireless, and now we are having real time with low latency, clear air, and very fast convergence. And in the near future, that is strictly deterministic, we are moving towards time sequence, multi-path fusion. And that is the area that we need to understand for swarm drone network, advanced flying ad hoc network, underwater sea ad hoc network, and many more. I'll just wind up the lecture now. So this is the architecture that you can see, that how we are actually planning the command control network, the nuclear gas station network, and of course we can have the complete radar control system for flying vehicles when they come, and even the traffic monitoring system with autonomous cars. So believe me everybody that deterministic networking is the only architecture for future transportation system. Remember. So the conclusion is that the kind of exciting opportunities in networking and communication is very on, and we need to have more thinking towards human, social, and environmental impacts. And of course, there's a vicious cycle between applications, services, and innovative platforms. Now it depends on you. That is what you have to decide. That what area you want to research, because applications and the levels and layers are all open, and every layer and level there is a massive amount of research. And of course, solutions so that one day we should be sure that the research that has been undertaken in the last 6 years or next 24 years is actually taking us through that by 2028 or 2029 we can see these vehicles in our lifetimes. So research collaborations, you can see that these are the most important government involvement funds, NSF, DOT, and if you are interested for a research project on this area, you are most welcome, because very soon I will be giving up a collaborative project of about $600,000 to NSF and even to Korea Brain for autonomous vehicles. So if you are interested for wireless networking and communications, especially with intelligent sensors, you are most welcome to contact me. So thank you so much. Now the house is open for your questions. If there is any question, please let me know.
Dr. Nayar, thank you so much for this very detailed yet very simple talk that you have given. We will open the forum for the question and answers. The participants are requested to raise their hands in case they want to ask any questions, and our moderator will help us unmute them.
Yeah, from Harshal.
Yes. So, can we have Harshal's mic turned on?
Yes, Mr. Harshal, good afternoon. Please go ahead, please. And this one.
I'm very grateful that you have shared this valuable information.
How should is there a request to type your question in the chat box? From there, there's a lot of
Mr. Harshal, you can ask the question, please. Thank you.
But I believe Harshal is typing his question for a few seconds.
Okay.
Please while.
Question: how to deal with the privacy issues with ITS? So I have already told you that privacy is a big issue on which we are actually working. So actually, I'm not working towards privacy issues, but I'm working towards security issues. So for the security issues, we are actually working with blockchain integration. So how the safety enhancement will take care, which I've already told you that if you're in a vehicle that is having internet connectivity, and if there is a vulnerability with any sensor or any architecture, the hacker can do the exploit, or you can say the backdoor exploit with artificial intelligence, which is now a biggest weapon for hackers today. So they can even do the accidents, they can even control your car remotely. So for that, we have to make it sure that the safety and privacy is very important. So for that, we are only working towards enhanced blockchain system services for that, which are having advanced consensus protocols. Hello? Hello? Mr. Herschel, can you see me? Can you hear me? Hello? Okay. So Madam Smita has asked me a question, what is the difference between fog computing and edge computing? So the only answer that I would like to give you, that if you are working on a application in which the data is in motion, so all the data has to be collected with all the data is in a massive form, so only fog nodes can be there. But in order to accommodate this network, we need to add edge intelligence with the cloud computing. So in order to maintain the entire architecture, fog computing and edge computing play hand in hand. Okay, thank you, ma'am, for inviting me. If there is any other question, they can contact me. I can give my email address and everything on the chat box right now. Yes, thank you, ma'am. My lecture is over.
Thank you so much, Dr. Nair, for personally typing in all the contact details. I'm sure a lot of research aspirants who are interested in this field will reach out to you. And thank you for, opening the forum for so many researchers to approach you directly and taking the questions. Thank you. It was a real pleasure having you and listening from you. Our third keynote speaker, Dr. Devdutt Sheikh, is an assistant professor at the Department of Electrical Engineering and Center for Education in Artificial Intelligence and a joint project director at IIT Kharagpur. Let's see Dr. Devdutt's introduction briefly.
Dr. Devdutt Sheikh is an assistant professor, Department of Electrical Engineering and Center of Excellence in Artificial Intelligence, which is a joint project. He is a director at IIT Kharagpur, AI4ICPS, iHub Foundation. Dr. Devdutt Sheikh was born in 1986 in Kharagpur, India. He obtained a BTech in Electronics and Communication Engineering from the West Bengal University of Technology in 2008, MS and PhD in Machine Learning and Medical Imaging from IIT Kharagpur in 2010 and 2014 respectively. He was a DAG visiting PhD candidate at TU Munich during 2011 to 2012. Currently, he is an assistant professor at IIT Kharagpur with primary appointment at the Department of Electrical Engineering and associate appointment at the Center of Excellence in Artificial Intelligence. His research spans deep learning, digital health, and visual computing. He is a chartered engineer, senior member of IEEE, member of MICCAI, life member of Institution of Engineers, India, BMESI IUKRAI. Ajinkya D.Y. Patil University welcomes you to ICISI 2021.
Well, thank you for that, Devi. And Dr. Devdev, we are happy to have you here as the next speaker. I would just request you to kindly brief our participants and our live viewers on the topic.
Yep. Thank you. And it is great. I would have loved to be in Pune if it was in the good time. Your campus is really in a very wonderful place. The last time I was over there, I enjoyed spending most of my time just on the corridors to get a nice view of the hills and not pretty much in the crowded part of home. It's always a nice nature slap view which one can enjoy. Yeah, but then yes, these are fine times, and instead of calling it as we are tough times, I prefer to call them as disruptive times because we are really seeing a lot of disruptions happening in this whole period. And this is something about what we started more than a year and a half now. So it was in about February of 2020 that we formed a group in order to start working and understand about what would be needed in the next few days for COVID diagnosis. Now, the whole world was actually moving behind getting down RT-PCR kits, and somebody has raised their hand. I'm not really sure. If you have any questions, you can just write them in the comments. So, other than that, the only thing I wanted to ask is I hope my screen is visible to everybody.
Yes, sir, it is visible.
Okay, great. So, something we started in February was essentially to understand the radiological impacts of COVID. And the primary reason for that is while the world was basically going behind screening tests, there is a limit to what you can do with screening. There is a bigger thing which you have to do on diagnosis and post-interventional assessment, which basically means that if somebody already contacts COVID and they are giving certain medicines, and given the fact we know that COVID impacts the lungs, so what happens to your lungs is very important. So how do you really monitor your lungs? And that's something we started working on. But then I will tell you the journey, how it went on. It was a very complicated thing to start working on. There's an abnormality. Then we are able to take their X-rays. So we are able to take their X-rays. So I have a chest X-ray being taken. And then the idea was like you feed it onto a neural network, which is what anybody today thinks. That you know deep learning, so you can basically solve any of the world's problems. And more or less, deep learnings are getting very naively equated to AI models itself. But then that's not all of it. Let assume that deep learning is also one of those solutions for AI, and now we're able to get it. So from there, the idea was that getting an input to this one, if I have an AI model, then it should be able to write down a natural language equivalent reporting of this chest X-ray. And this kind of a reporting over there. So what it says is that there is some sort of a worsening of lung markings, which are more evident in the lower fields, but no clear consolidations. So this is how a radiologist typically reports out. If these models are able to report out as well as annotate and show, like this is where exactly I am seeing it, then you have something which is called as an explainable diagnosis. Now, these kind of explainable diagnoses are stuff which are trusted, they are trustworthy enough to go down, and other doctors would be trusting them. The advantage which you get with this is that the number of radiologists within the country is significantly low. So we just have 10 radiologists for every billion population of Indians. So which would basically bring it to some 3,000 radiologists in the whole country. Now, the issue which comes out over here is not 300 radiologists. So the issue which comes out is that if you have such a less number, then how do you really get these reporting worked out? Because your internal medicine physician or your pulmonologist, and all of them would be needing these kind of radiological reporting coming. So then we come into play because my group as such works on digital health, specializing on medical examinations. So if you just key in that particular word over there, you would expect to stumble upon some of my NPTEL courses on medical image analysis, and that's essentially what we do in order to make a living. Now, the question over here was that go around claiming that we solve great world-class problems. In fact, like we do solve some of the challenge problems every year, and when we say that we solve, we basically come to an end solution of that. So there is nothing else left to do in medical image analysis after we provide a result. We actually work on a lot of problems. So as a result of which, it looks to people that we end up one problem at a time in India, but it's a subsequent number of years of effort. But then when it came down to COVID, we were actually as ill-equipped and as ignorant as any other. Then people would come and yes, they would expect that as if you know everything. Now that's not how it happens. So this whole talk is going to be a journey of how we get one thing at a time. So one small problem at a time, and how do we really go around the problem. So the challenge which comes out is, the primary thing is that I want to train an AI model. What do I need in order to train an AI model? First thing, I need data. Now, these are going to be radiological images, and radiological images can come down from multiple sources. So you can have an ultrasound. For test screening, it is what is called as point of care ultrasound or focus. You can have X-ray, which is more predominant in India, but then if you ever look into CT diagnosis with radiology, then you would find out that everything was being done on CT, which is a very much Western world equivalent. But if you look into India, then we don't even have that number of ICISI scanners which are needed to scan the lungs. So the lung scanners themselves are specialized versions of CT. They are a bit costly machines called as high-resolution CT scanners. You don't have access to that. But we have a super access across the country, length and breadth of the country, including a lot of village rural healthcare centers. Now the point is, one is you need to zero down on what kind of a modality you will look for, and we really needed to be open to all of them. The next part over there is to find out what kind of labels you have. Now what that means is that these images which you get from these machines, they need to be annotated. So certain things need to be mentioned out here. Now the problem is,
वो तो भेज दिया मैंने, वो जो उसका रिप्लाई आया है ना, मैंने क्या न्यू मेल भेजा है लोकेशन
on my cup of tea. It's actually quite long since I had my breakfast. Now here you have these labels which you see over here, and these labels need to be obtained in a font where they are sort of binary. Now what that means is that is something present or absent is what you need. Now if you translate it into a very simple font, it boils down to a checklist. So somebody needs to have a checklist of what to see in these modalities, in these images which come down to you, and then report whether presence or absence of a certain thing is associated with a certain disease or not. Now here comes another set of problems when you have to do that one. How do you get this checklist? Because the disease is new. What you have to see is also new. You don't know exactly what you need to see. Then how do you create this checklist? Is the question. So that's what we wanted to solve over here. The good thing is that when we were doing it, say somewhere in March 2021, by the time we understood this, 2020, so March 2020 is about 15 months per year. By the time we understood this problem, one great thing was we had a lot of samples. So there were like about 2 million people on planet who were already affected. And so the number of samples was not a problem. The issue definitely was that you did not have a reporting and data system available to you. And because there was no reporting and data system, so you don't have a standard form of label. On top of it, the bigger problem was that not all the million cases were actually imaged. So you did not have these images available for all the million cases. You would have it for less than 1% of it. But even less than 1% is not a bad number, because you will, less than 1% of a million is still 10,000 cases. 10,000 scans if you get down, you are really rich, super rich in terms of the data distributed to you. Now, this whole thing that you don't actually have labels or annotations available in a standardized form is what makes it challenging. And that's where this problem now started to seem like unsolvable, although we were sitting on top of it. So now, what this boils down to is, can we really look into the data and quickly use AI tools and techniques in order to evolve with this checklist itself? And that's what was the first problem that we wanted to start tackling. So the COVID-19 Action Group was actually born. So it's a pro bono initiative. It means that a lot of people who professionally do either radiology or chest medicine or do image analysis, we came together and we created this group in order to be working together in a coherent manner. So we are officially affiliated to different institutions and everything. I hold my official affiliation to IIT Kharagpur. And the COVID-19 group has a lot of people from different other institutes as well, institutes, hospitals across the world, everybody. Now, all of us together started writing this one so that we are able to find a solution. If not anything, the first nominal thing is that checklist, which even is immensely important for reporting of these X-rays of the chest, X-rays or CT scans of the chest in a standard clinical setting. So this is the scene, and the kind of expertise which we have actually spans a very wide range in AI applications. And we are really fortunate that we had the support of a lot of standardization bodies and collaborators, like Focus Atlas, which is a standardization body, and another pro bono initiative, the RSNX, which is the Radiological Society of North America, and predominantly most of these radiology reporting standards in the world are created by them. Then also the Indian Radiological and Imaging Association, which was really proactive in promoting us to their forum pretty early on so that we are able to provide some certain solutions. And then we had a lot of these hospitals come down, including Valdecilla, which is from Spain, and it's one of those from the northern regions of Spain, which actually had a very bad impact of COVID in the first phase itself. So we were getting those real-time scans and annotations from them in a very fast form. Then we were also part of this COVID-19 challenge in the EU, so where the kind of reporting standard which we created actually helped them in have better quality standardized annotated data, which made it much better for them to also build out models. So what we did and what we do, we still continue to exist. Maybe we are not that high in number or we are not that much proactive now, but it still continues. Now, let's look into this problem in a straightforward way. So what we have is, say that there is a city which has a hospital, and let's call that hospital as hospital A. And this hospital has a certain number of beds. Okay, I think it's 20 beds or something. Now in this city, what happens is something. So one patient or one individual in this city got affected by COVID on the first. Now this guy actually, by the time he was diagnosed and found out to be COVID positive, he actually went around and had contact with a lot of other people. So he was sort of an active carrier as well. And then when he had fever or something, he got admitted to the hospital. Now he gets into the hospital, so the hospital caseload is 1 on day 1. On day 2, there is another patient who is now found positive, and they basically admit this person to the hospital. So now your caseload keeps on increasing. So if you keep on admitting one person to the hospital without them exiting, and they are still in treatment, then your caseload is sort of like really increasing over there. Now, if I go to it and at the end of the 20th day, if I'm able to exit a patient, so if a patient is cured on the 20th day, then what it will look like is that every patient cures goes out. So there is a new patient who is affected, comes into the hospital, so there is one bed which is getting piped out on a daily basis. So now you know that sort of like if you keep on going like this, you will never be left in a city where you have untreated population. So this becomes a very steady state scenario. And in fact, this is something which we are always trying to achieve with imposing these lockdowns. I won't go into that whole argument and policy around lockdowns and everything. I am a critic which supports it both the ways. It depends on my mood. Sometimes I say that lockdown is good, sometimes I say that lockdown is useless because you are just delaying your decision as miserable as you are. The point is that this is the scenario that this is what looks like. Let us consider another policy. And I will say, like, once you are treating all the patients, like, there is no more patient who is getting affected in this one and your case will build. Then what happens? Like, you are the first wave and you have been completely tried. You are treating people, the rate at which new people are getting affected is lesser than the rate at which you are able to cure people, so your case load and over there. And then they have all of these policies of lifting lockdown with just taking time. But you lift the lockdown and then people again go up and then that's how the second wave comes in. Then the third wave will come in, then fourth wave, and most likely after the fifth wave, most of the people would have been busy antibodies.
So it is an honor of Nobel laureate is coming and speaking.
Now say you have another hospital, another institute, so you have the same number of and this is the hospital. Now what you find is, like there was every day there was one patient who was getting infected and that one patient was getting hospitalized. So at the end of 20 days, your hospital beds are completely full. Now what happens interestingly with hospital B3 is that on the 21st day, hospital B is not able to discharge the patient. So it's not able to cure at least one patient, or the patient who got admitted on day 1 was not cured by the 20th day. Now as a result of it, what will happen is that for the 21st case which comes down, you don't have a bed in the hospital, so that person has to stay at home, or basically out of all the hospital care and bounds, they can go around. In fact, like if you are staying at home, who is going to bring you food? You can cook your own food, but the point is that who is going to bring your groceries? So you will still have to go to the grocer, get your grocery and all of these. So which means that these are sort of symptomatic individuals who are just roaming around over there, and they are much more riskier. So this is what creates a problem. You have from one individual you will see 2 individuals who get infected, then 4 individuals who get infected. But the number of people in the hospital is already full. You cannot take any one person. So now this is the point where you would see that since you are not able to get people admitted into the hospital because you saturate out on the bed, so your number of untreated cases is increasing, and that's increasing exponentially. It actually follows down a standard geometric progression rule if you look by it. And if you come back and ask me this question, then who is responsible? Honestly speaking, the responsibility is at the point that the medical system was not able to optimally treat somebody in 20 days. But then this is much easier to blame than to actually solve this problem. It's not an easy problem. It's really not as easy as contacting COVID itself. The easiest of the interventions always is lockdown. This one is really the toughest problem. I mean, if somebody says that lockdown is the last resort to save human civilization from contacting, no. It's the first one. It's always the easiest one. It's like, there is disease out over there, don't go out. That's the easiest. You just have self-restraint, you stay over there and then you will not get infected. The hardest is always that you contact the disease, you are cured, and you are cured of the form that you don't have a post, like after you get it cured and you are treated, you don't have any other problems in your body. Now that's the toughest one. The problem is we are trying to solve that task. So our whole point was, you can lift up lockdown only under a condition where the number of people who get admitted to a hospital on a daily basis is equal to the number of people who are treated and exited from a hospital on a daily basis. So the rate of new cases, rate of generation of new cases should actually be lower than the rate of treatment of existing cases in a hospital. And that's the golden point when everything will work out good. Where can the difference come? So essentially, you can optimize all of this only when, say, there's all these physicians who are in both the hospitals, they start speaking with each other and tell each other, like, what kind of treatment did they administer, which led to a faster outcome. So essentially, hospital A would tell the people in hospital B that, see, this is what we were doing. So our people were getting treated in 20 days, and then they could go out, and then you can have enough of access for other patients to come. Now, let's look into how this can be mathematically different. Because all of this boils down to essential statistics at this point of time. What would happen is something like this, that for different hospitals there can be two different age groups of patients, and in fact, like, it depends on the incidence of what they are going to treat. There can be multiple kinds of treatments as well. So as of now, we are assuming that there are three kinds of treatment which can be done. Now, dependent on what kind of a patient group, which is age group and weight group, your patients are predominantly coming, they might respond good to one kind of a treatment, and the other might respond to another kind of a treatment. So now what it turns out is that for hospital A, the kind of age group of people they had, the best outcome was for treatment B. But then if you look into hospital B, the best outcome for them was in treatment A. Now if hospital A's whole protocol is shared with hospital B, then you know that hospital B will also be following treatment B. But then hospital, this treatment B does not work out the best in hospital. The chances of that is bad. The point is, how do you get these chances? So what I made down in terms of these bars over here is essentially, this bar graph is essentially going to show you something which is called as a posterior probability of success. So let me come to that from a very much rule-based estimate. Now, what you need to find out is this, which is called as probability of success of a treatment for a given patient group. If I say that this is a probability, then all of this is what is called as a evidence-based medicine. So essentially there is a whole field of medicine which is taught to medical students, which is called as evidence-based medicine, and this is also known as quantitative medicine. The whole aspect is look into retrospective data, which is whatever is the historically available facts which you have, and then from there try to find out that under what conditions was a success guaranteed and under what conditions it wasn't. So this is a very critical point. So now, if we look into that, say the probability of getting the success of a treatment for a given symptom, if this is what you need to obtain, then you can actually write it in terms of product of the likelihood of that symptom for any kind of for all the patients who are given a certain kind of a treatment, the prior probability of administering that treatment, divided by the evidence of actually encountering that symptom. Now, when COVID just suddenly started coming in, the evidence of the symptom was also ill-defined. The probability was so low. So all of this uncertainty was very high. Actually, P of S was near zero. Actually zero. Because the P of S was zero when you had the first COVID case. So this was an ill-posed problem over here. You can never solve it. So these are kind of standard problems which come down. And that's the reason why the first case or the first few cases, they need real attention because you don't actually know what is the symptom for this. Now comes the point that if we break down this whole problem into this way, so there are say two age groups and there are two weight groups in which I see my subject over here. And I wait for a couple of days, say up to day 3, and then look into populating this table. So now what I am doing is, I will use 3 days of my information. In hospital A, there was one patient who was getting admitted every day. So in 3 days, they had 3 people. So you had some number available to you. And then on the 4th day, you wanted to actually find out this evidence or what is the whole thing going on. Now, in hospital A, what you had is that all the people who were admitted, they were all belonging to age group 20 to 40 and weight of 50 to 60. The issue was that the other 3 combinations, you never even had a single patient over there. And this is really complicated because on the 4th day, if one patient comes down from any of the other combinations, you really don't have any way of telling them how I can administer a proper treatment when you will have a good outcome. So this becomes a key over here. So this is not a solvable thing. And that's a very solution now. And this comes down from very standard basic logic. Point is, how do you now, for a COVID case, the thing was very simple. In the early days, if you remember a year back, people used to say whether you have cough, whether you have fever or not, and then can create some sort of a checklist, and there will be a red flag for something. Now, there were issues with pre-existing diseases, whether you are hypertensive or not, whether you are diabetic or not. If I have all of these 4 different aspects on which I want to do it, then there can be 16 possible combinations, which can be represented as a gene. Now, on top of it, say that there can be a combination of interventions given with just a number of drugs, medicine, and also have some sort of device connected to them. So either you are incubator or you are put down with some sort of an oxygen concentrator pump or something support device or an artificial lung. These kind of things, they can be multiple devices. So now, if you look into this granularly, your whole data space can be divided as for the one device, one combination of those combinations of
इसको फोन करके बोलता है आज चाहिए तो
your treatment is
मैंने उसको झट से फोन करके बोला भाई टाइम लगेगा सैमसंग की तरह ऑफिस का और वो भी देखो कितने ट्रेन में भेजे उन्होंने 6 तो है वो एमबीसीसी
64
क्यों प्लेटफॉर्म एक प्लेन में प्लीज ऐड दिस प्लेटफॉर्म एक एक्सप्लेन टाइम एक्सप्लेन आखिर में मैंने उनको रिप्लाई किया प्लीज काइंडली सेंड ऑल इंफॉर्मेशन इन वन फाइल
only after we put that funds over there. And now you should understand that the reason why in the early days when you were getting admitted to a hospital, you were never able to get on a proper treatment because the hospital did not have enough proper data to calculate out on what treatment is the optimal treatment. They still needed 2 months in order to clear it. So this is just a mathematical way of expressing why that would be super delay and uncertainty was present. Now the point is, when we looked into the multiple hospitals, and if you try to collect all the data, you will find out that you don't need to wait for 64 days because from multiple hospitals for a small span of time, I can just put down all the data. So say in 10 days, if you want to collect down 10 data points, then 6 hospitals in 10 days will be able to release 60 data points. The issue is that they might not be able to cover all the points. There will be some hotspots. These blocks will be in solid colors and not dotted. So these are the schematic representation that those are the ones where you have the majority of the output being exported, or the other ones are zero, not actually see anything as a simulation from all of these points. So this is important to be able to turn out from the data. And once you are able to do that, then all the problems. The point is, how do you get all these hospitals to come and get the data when they are speaking? So here it comes down to the interesting point that over a period of time, because the whole disease has evolved in China and in a significant other parts of the world, in Europe and US as well, much ahead of when it started in India. So they were already suffering from it in October, some places from December, some places from January. So people were publishing out significantly in these medical journals, and that's where all our pressure goes. You have all of this knowledge which is present in these kind of information dissemination in terms of case reports and panel studies as well as standard research technology. Now, the issue is still that there will be quantity factors, and that's what we wanted to find out. Next major issue is that most of the developed world was publishing out their findings and everything in different. The developing world was doing it in reflective X-rays for people like us, and the underdeveloped world was much of relying on ultrasound, which is majority of the African continent as well as a lot of our neighboring countries. India is still far better because we never needed to rely on ultrasound. We had access to X-rays, and that was working out good. And to a very great extent, we also had access to CTs, and a lot of hospitals have actually started procuring CTs to our refurbishing their old CTs in order to service them. So there's somewhere between the X-ray and CT that gamble. It was mix of data. And then the issue is that we never had this kind of a reporting system created to create that checklist. Why we started down is that the checklist, what should it have? So one is that it should have a place where you very distinctly write down what are the symptoms and you tell the radiologist exactly if look for these things only. Then you have observation, you have this presence in the space or not. And then you do a trial. So we basically solve this whole agentic problem because otherwise it would be like too mathematical into just a checklist and then a recommendation suggestion. The whole issue is that I mean, when you have this, what you can do is that somebody comes to the clinic and has this kind of instead of clicking and then you can give down a set of options. Now you can accumulate this, all of these information going down together, and you actually have a rich treasure trove of data because when it comes down, the problem is how do you essentially solve this? The whole issue. So that's where the COVID-19 actually built up a whole platform, and this platform had this four attributes over there. One was like edition to quantum, data and
editing चालू करा.
We were building AI models the COVID-19 that was like us, we were AI research. In terms of Monday. Reports and findings and then publish how AI models and then we are sharing out AI models as well as white papers written down around them and people have a know-how what how it works.
busy है ना 2 दिन. कल करना है क्या?
I wanted to have some sort of satisfying information. So we said like don't think like model. So let's break it up. Like what can it solve in the so there are certain low-level problems. There are certain mid-level problems and there are certain high-level problems. And we started with this low level. So, as an example, if you look at when we're trying to build up this COVID-19 brand, what we did was something like this. You do a web crawl, get up a lot of articles over there. You do some sort of a context and alias reporting where you find out those images, capture some other images, and then segregate. Okay, this is an image, this is a caption which describes the image. We take those text over there, the text element, match it with words in RSNA and SPSS. And once we match them with all of these keywords, now what we have is a set of tokens which are known and a set of tokens which are not known. And that is used for automatically building up the first version of that. You run it through radiology and do a panel of images and then see what to do, what not to do. And then we came up with the second version of it. This is what this looks like. And interestingly, the way we discovered this in an AI-based method, and this was done by the end of March, we already had this. So March of 2020, we had this kind of a checklist already prepared. And that was the first kind of a checklist which came out for radiology reports. And we were not only for X-ray, we had X-ray, ultrasound also. Somewhere around September 2021, there was a similar thing which came out from RSNA. The whole business was that RSNA actually got down a lot of expert radiologists sitting down together, discussing, sitting down together on a good story, and discussing in order to find out this. That took them 6 months more than us as an effort in order to come up with this component test. Whereas because we were not using human beings at that point of time, and were rather using AI in order to do the first level of search, and in the second level we were using human beings that actually verify whether whatever has come from the AI model is actually trustworthy enough or not. So it made our work much more faster as a deliverable than anything else we have been done. So finally, at the end of it, what I have to look into all of this, and it took us about 40,000 years to come from the cave to civilization. So it's just about 3 months of COVID, and then we were again pushed back into our cave. We were just looking into staying in isolation indoors and not even doing that. And the way you can again get back into that form is that you have a lot of knowledge, you have a lot of information, but you need to get down into actionable insights from them. The COVID-19 action group was one of those endeavors. The RAN which we created is one of them. But today we have a whole plethora. So we have models which are now getting commercialized with writers. We have papers which are now getting published. This year has one of papers which come out of the COVID-19 action group for burden of 40,000 years. There is an interesting paper in terms of how knowledge from multiple sources of data, which otherwise not so well known. So, I would come to an end.
सुबह 8 बजे कर देना तो कोई दिन का स्लॉट मिलेगा तेरे को. बेस्ट टाइम सपोज जो दिन तू
Thank you so much,
I would
Dr.
suggest you
Deshmukh,
go between 1 to
for
2.
this wonderful talk.
It is
Participants,
empty.
if you are having
Exactly.
questions,
यानी गर्दी नहीं
request
क्योंकि
you
केमिकल
to
मुझे
raise your
आधा
hand,
घंटा बैठना पड़ता
and
है
we will allow you to unmute yourself, or you also type in the chat box.
बट अभी भी खाली है एक्चुअली बहुत लोगों ने ले लिया है कौन सा हो गया put that pin code.
Dr.
It will
Deshmukh,
show
at
you
the
logo
moment,
or some शिशु केंद्र
since we are not
something.
getting any questions, and we're in
Cut
touch
those
with time, I believe we can move ahead. But thank you so much for this wonderful talk once again, and it's time now that we hear about our next guest of honor, Dr. Rajiv Agarwal. Dr. Rajiv Agarwal is our last keynote speaker of the day, and he's an associate professor of mechanical engineering and associate dean research at MNIT. So let us come together and watch his AV of introduction. Thank you. Dr. Rajiv Agarwal. He was more than 20 years professor. Dr. Rajiv Agarwal received his MA in 2001 from MNIT, Allahabad, and PhD in 2012 from the Indian Institute of Technology, Mecca, France. He's presently working as an associate professor in the Department of Mechanical Engineering, MNIT, Dr. Rajiv is responsible for the production of new products by developing can be improved, graded, and reconfigured in response to fluctuating demands of automotive companies situated in India. Dr. Agarwal is an active member of several dynamic societies and research projects. He has research funding from major funding agencies including Aviot Architecture of India under NPASS and ICISI. He has published book chapters on Industry 4.0 and smart manufacturing integration of process planning and distribution. Aditya Devi Bharati University welcomes you to ICISI 2014. So thank you for that AV that was played. Dr. Agarwal, we once again welcome you, and we're pleased to have you here, and we're eagerly waiting to hear you speak on intelligent manufacturing.
Thank you. Thank you, Dr. Rachna and the team of ICT Academy. And I truly overwhelmed with the participation of the quantum of your program.
ये ऑफर है 450 के सब्जी पे एक्सोटिक वेजिटेबल फ्री मिल रहा है ये हफ्ते का अपना अपना अगरवाल वाला सब्जी वाला
So I'm just starting my your voice is not coming.
Am I audible now? Dr. Agarwal, I can see your mailbox at the moment on the screen.
No?
Yes, now we can see the presentation. Okay.
So my topic is advancement in intelligent manufacturing and industry perspective. So my introduction already has been given by my committee. So I belong to NIT group, and all are welcome in any future for research event at NIT group. This is one of the top NIT in India. So you can see that this is India's largest complex and mechanical. My introduction already has given a part of that by my So basically, next half an hour I wanted to give you a scenario perspective of industrial manufacturing. The perspective in intelligent manufacturing towards industry, towards how government initiatives are there, what are the global scenarios?
स्पेलिंग मिस्टेक्स है इसमें स्पेलिंग मिस्टेक से सब
government
बट
working
देवांशी को चेक कर
manufacturing industry
उनका ही गलत है तेरा नहीं है
what are the
उन्होंने
basic
दिया है
and you would like to see basic application in one is only another is steam making process. So there are two applications you will be seeing. So first question is our mind is coming is working intelligent manufacturing. And the intelligent manufacturing has started. Where exactly people are working. So important role is
इनका सेशन अभी चालू
data,
हुआ है
where people think it's analytics is where data transition is there, but I can say there are tons of data which manufacturing companies are handling, manufacturing product, manufacturing parts, number of items. Data role is very important in manufacturing. That is why data analytics is very important in manufacturing.
नीचे जा जा
Which are actually enabling features we would like to know enabling features and how what are the various existing features and how this various enabling feature has enabled
कूपन्स तो देते ही है ना भाई
लास्ट ईयर से चल
कूपन्स का रूल ही है वो कूपन कोई भी खा गया
हम लोग पहला बोलता है मेरा
people are thinking
तो हम लोग कूपन तो दे नहीं सकते दूसरों को
converting into
हम लोग
their
बस प्लेट
company
होती है
into industry 4 perspective or they wanted to make their product
एक ही प्लेट जो सेकंड
they
शो में
wanted to
लेना
make their product
तब उसी प्लेट
industry 4 perspective
बंदे
but
ने प्लेट एक ही होती
they are
हाँ
last
तो उसमें तो घाटे होते हैं तो फिर केटरर के घाटे होते हैं उसमें शादी में तो और भी अच्छा रहता है हम खुद रिलेटिव्स को बोलते हैं प्लेट ज्यादा गंदा मत करो शेयर करके खाओ
second is
that is every family not only us but most of the families do that because you charge plate wise some people just take one dessert in a big plate और वो भी एक प्लेट गिना जाता है केटरर के पास फिर
data
इससे अच्छा
capturing
खाओ एक प्लेट में ले भाई मेरा हो गया मैं तू खाते प्लेट में टिश्यू पेपर है पोंछ लेना प्लेट को के
converting a line to machine from running one product to another that is
वो यहाँ तो चीज है
difficulties in traditional manufacturing.
आ गया तेरा कूपन
So lack of proper information and data of production line is actually the main crux
और ये शॉप करना
where this conference
इसका खत्म हो जाएगा
जैसा इसका हो
can issue
आधा घंटा तो मिनिमम लगेगा
this
He
conference
just
can
started.
actually
उसके
address
बाद
these
मेरा
other
वाला
issues
जाना वो भी स्कूल
in
है स्टॉप स्ट्रीमिंग कर देना बाकी
in the near future.
कितने बजे
So I just wanted to give
ये
the
शायद आधे में
global
लगेगा
scenario
देखते रहेगा लगेगा तो फोन भी कर दूंगा
intelligent manufacturing. This manufacturing is now people are talking about intelligent manufacturing, smart manufacturing, and physical industry 4 has started in 2011. The industry 4 work started in Germany, from Germany. Now, same year, US has started advanced manufacturing. They wanted their industry to be an equal, competitive ecosystem. So basically, they have 6S programs. So one is space, semiconductor, shell energy, smart ICT, silicon, and sustainable development. They were advanced enough in that particular time to have this kind of 6S program. Then 2012, Germany passed high-tech strategy 2020. Then 2013, UK started future of manufacturing, which they wanted to go for till 2050. Then European Commission announced the program of factory future in 2020. Then China issued the Made in China 2025 and along with Internet Plus plan in 2015. And 2015 Japanese super smart society. They had main emphasis is with the help of strong SMEs and Keresto ecosystem, they wanted to have more super smart. And then Singapore committed 9 billion research innovation enterprise. Since last 10 years, the intelligence manufacturing has now has intelligence in both continent. And if we talk about India, so India has started this in 2000. So with the help of various ministries, this our Honorable Prime Minister launched the fourth industrial revolution, where he started a Samar Udyog initiative for ecosystem propagation of industry. So basically, they gave the fund in the name of cyber physical system, which is the name was National Mission on Interdisciplinary Cyber NMICP. So they have 3,660 crore for a period of 5 years. So they are establishing NMICPs in various NITs, IITs, and including different center of eminence status institution. So basically, they wanted to go for only manufacturing sector. So mission to create seamless ecosystem. Since manufacturing data is like one element in manufacturing job which we created that 10 that is the problem for them. So there are various is into this system. So first is Rail, Ministry of Rail. The Ministry of Rail actually wanted to go for full transition of digital factory. For whole value chain, ultimately they wanted to enhance productivity by providing insight into production process. Now, to take decisions in real time and minimizing human error. And ultimately they want to monitor how their resources are utilizing and how overall equipment effectiveness is. So that is the first. This factory started in Raipur. Second is Ministry of Railway. They have a technology solution. So DSP supported project. So ultimately their protocol is centralized data signal processing for whole design production. So now possible to monitor the manufacturing process in real time for enabling optimization, planning, scheduling, decision making in dynamic in multidisciplinary. Basically to enhance production. So that is the Ministry of Railway initiative for rail wagon manufacturing. Now, as you know, the rail has the biggest infrastructure sector in India, and there the first initiative has started in railways. Second is Ministry of Commerce and Industry. So through summer, Udyog Bharat Department of Heavy Industry has enhancement on competitiveness in Indian capital. So basically, they has four centers. First is Center of Industry, Pune, then IIT Delhi, Foundation of Smart Manufacturing, then ICISI Factory R&D platform, and then Smart Manufacturing Demo platform at Central Manufacturing Training. This is the banner of Ministry of Electronics. Now, Ministry of Electronics wanted to produce 11 crores and export, wanted to export 7 lakh crores in next 5 years. So they also wanted to have strong position and they wanted to have electronic manufacturing. From railway to commerce to electronics, they wanted to generate more job into this. So basically, there are different fields in this. One is data analytics, 3D printing, AI, virtual reality, robotics, machine-to-machine communication. Now, one machine can communicate with another machine with the help of agent-based manufacturing. So, I have one of the paper in machine-to-machine communication where machine can communicate with another machine, and there are smarting of legacy machine. So, Ministry has this particular area. Now, apart from that, there are 8 centers of excellence for technology development started. The first is COE at CMD Bangalore. Second, so they started developing a shuttle-less repair delivery. Another is at IIT Madras, 11 advanced technology for machine student production technology. Third was in PhD for building technology. Fourth is in Coimbatore for smart submersible pumping station and water supply. Then for textile machinery, for advanced manufacturing and ICISI for manufacturing hydraulic. So there are 8 sectors are there. IIT Bangalore, they have MOU with Wipro for design development of 3D printing technology. Now, impetus has been given in these areas. First is 3D printing. So this 3D printing small jet shape which exposed to light. So basically, these are being used for soft robotics, where muscles of that robotics is being created through 3D printed discs. Now, for transferring process using conventional process, you converted into automated process. Now, various researchers are preparing a wearable sensor by 3D printing, ultraviolet.
कढ़ाई लेने का उसमें से ऐसा ऐसा करने का काम करके फ्राइंग तेल तेल थोड़ा सा नहीं डालने का तेल में जीरा डालने का हां फिर उसमें पानी डालने का उसको बॉईल करने का हो गया तो बीच में फोड़नी हां फोड़नी उसमें जीरा और हां वो करी ना करी बोल दो अरे करी नहीं कड़ी होता है करी सब जो पतला है ना सबको करे दाल दाल की करी में दाल ही होती है जो लिक्विड में फॉर्म में बनाते हैं उसको सब करी दाल में करी बोलते हैं छोटा छोटा गोभी इतना छोटा मटर डालते हैं हल्दी दाल फ्राई करो तो बटर हल्दी नहीं डालते मम्मी बनाती है
Dr. Agarwal? Dr. Agarwal, I hope I am audible to you.
जो लोग नॉलेज करते हैं लहसुन प्याज अदरक इसके बिना नहीं सकते हो अरे उसके में टेस्ट आता ही नहीं
Dr. Agarwal?
मैरिनेट करने के लिए तो आपको आधा घंटा वेस्ट है लोग कभी-कभी दूसरे चीजों का स्मेल ऐसा खटकता है लहसुन गरम मसाला चाहिए
I believe the speaker has got locked down. So let's few minutes and we'll get in touch with him.
दो लहसुन पूरा डालते थे खाना बना कुछ भी बना रहा लहसुन भर करके मैं चाह लहसुन गिन के डालूं वो पूरा का पूरा लहसुन पेस्ट बना के रखो देना वो बेटर है आपके दाल के लिए आशा रखा लहसुन चाहिए तो ये करके डालना दाल को दाल दूध दाल आप ऐसा पेस्ट बना के करके अलग लगता है स्लाइस करके काटना फ्राई करने में स्मेल आती है बहुत मस्त
We're trying to get in touch with the speaker. I believe there must be some technical glitch at his end. I once again request all the attendees and our online viewers to be little patient with us.
नहीं मजा करता है वो लोग दाल फ्राई करते हैं तड़का बाद में डालते हैं तड़का के लिए वो पैन अलग से आता है उसमें वो इतना छोटा सा गोन उसको जो मिर्ची होती है ना वो डिफरेंट होती है सूखी लाल मिर्च होती है और घी रहता है और जीरा रहता है उसमें उसको अलग गरम करते हैं
Dr. Agarwal, I hope I'm audible to you.
Yes, there's some disturbance. I think I got disconnected. I'm just reviewing right now.
No problem. Thank you so much for joining us back. And over to you once again, sir.
Yes, yes. So I was just discussing about transforming process using automation and research and how researchers are preparing variable sensors. Then touching less, worrying less, which is now in this COVID area, COVID particular scenario, where people are talking about the more remote sensor enabled products. Now, how 5G and IoT works from manufacturing sector in 2021? This is actually now the manufacturing companies are looking. Now that is why government is also giving full support on that. So, with the help of this, government has started one very big and good initiative, that startup awards. So they have given a startup award in 8 categories. So first in 3D printing, they've given this one company for capability using carbon fiber as a raw material. Another for AR products as a variable, where 3D and AR experiences while discovering it through cloud and web through app installation technology. So these are actually technology which enable any manufacturing intelligence. Third is big data, where one company, I am not giving a company names, this award has been given for need of plant enable that predict and performance issue in advance before that significant. So before papers, they can predict equipment. Uptime AI. Another is comfort computer vision. So they develop wearable products to support the visually impaired for living. And their 3 solutions is given for learning and application. The last is Internet of Things. So these award has been given these categories, and broad categories for industry 4 categories. So IoT based platform for increasing energy efficiency. Ultimately, there are 2 things which are important for any operation. One is efficiency and other is productivity. So they were machine learning AI to derive actionable insights. So that is called in real estate establishment. And in robotics field, underwater remote operated vehicles for underwater inspection itself. So basically, there are a number of applications they received in big data in these 8 fields: big data, Internet of Things, 3D printing, cloud computing. These are the enablers for manufacturing, where and when manufacturing can become intelligent. In 2020, government started a blockchain-based verification system for startups. So now they receive number of applications in different sectors. So I am just only talking about intelligent manufacturing aspects of it. So there are a number of sectors, 12 sectors are there. So I'm not talking about the sector, I'm only talking about manufacturing. So one company has given a award for they develop AI for plant monitoring. So plants to be monitored, run effectively without surviving. So where actually you can identify cause with unique system approach. So that is a complete solution has been given. Then learn and adopt with autonomous AI and solve complex problems with diagnosis and economics. With the help of these 3, where AI, this particular solution can predict and fix issue as well. With the positive time, actually, one of my case study, with the help of one scholar, we developed a quality issue. We developed a quality control in one steel industry, where we implemented automation for for actually rolling rod, where actually we predicted and fixed the issue for that particular rod. That project is actually in full stage. Still, we have some a failure IPR issue. Actually, we will certainly have once it will be materialized. This is for these are things from my one paper which I published in ICISI journal in 2009. So where I developed a e-manufacturing framework, where 3 different companies, one company is producing product in 3 different locations, and I developed a process plan for integrating manufacturing. So I developed a multi-agent based computation, where agent can enable new knowledge, and agent can distribute information, can coordinate with information, and can cooperate with automation. I can give you the one simple ये statement बना होगा in your inbox. If you wanted to see or if you wanted to stack your all email folder first and your last, just go and click one button and that email will does this. So that is what agent is. You are giving it information, and this operation is automatically enabled and executed and given out. So that is exactly agent is. Now we developed a wide agent, manufacturing, scheduling, planning, role management, and design. So where machine to machine communication was there for three aspects. So what they are so we actually had where plants being selected with order processing means process planning. So for process planning, you require machine to be selected. If any product has to manufacture if any product has to manufacture, this product must be having a number of operations. It may be drilling, milling, grinding. So there will be a number of operations. So which operation to be performed in which machine? So that need to be selected. Then for that operation executed by a number of people, and then tool approach directly. And then texture to. So this is what is exactly process plan. And then while doing so, you have to minimize the machine. So there are two objectives which you are simultaneously doing. One is processing of operation, other is cost. So there are multi-objective optimization is there. So now, with the help of these enablers, plant monitoring is possible. You can have three layers. One is sensing. You want to sense your equipment. You have got a sensor layer. So it can be enabled by RFID cameras and audio devices. Another layer is network layer. It may be a satellite or website through mobile or wireless. And third is application. So now it is enabled by three big technologies called distribution, supply chain, and smart working. So there are a number of operations where these plant monitoring is going on. Ultimately, what we are trying to fix. So first is you have a problem in that which may be executed by the experienced people. Now you are using this data to build relationships what future is going to happen. Now how this machine is going to behave. So that data is now converted into knowledge, which is now converted into artificial intelligence. Now that craft, earlier we were having a craftsman, we were making a perfect product. Now we are having these problems in the form. So we are capturing this data, and this data is being used as an experience-based manufacturing, which is now converted into agent-based where machine learning algorithms are being developed. As I told you, there's very simplistic example I have taken. Another is predictive analysis. Either way, so earlier this experience-based manufacturing now data number of things like supply chain management in kind of ERP where you have a supplier machine, you have a machine product people, and you have a machine product people. So ultimately what our intention is the manufacturing. So where manufacturing has started with first revolution, now it has come. So that is what cybersecurity is. Now with the help of technological assessment and advancement, these machine equipment are doing AI traditional manufacturing becomes intelligent. Smart manufacturing has emerged as a new version of intelligent manufacturing reflecting the magnitude and impact of the work. So if you categorize intelligent manufacturing, basically they refer to three elements. One is data. Their data is being collected from equipment, product, and process. Then you have to do analytics. analytics can form of predictive big data analysis, industry 4, cyber physical system, agent. As I told, the agent can be machine can become a one agent, cyber physical system, and display. Third is smart industrial, where data analytics provides a feedback loop for optimal business decisions. So business decisions are cost basis, time basis, productivity basis, efficiency basis. So we wanted to understand equipment state and production process. So ultimately, machine to be monitored, maintenance, which need to be done with the help of predictive analytics, and then you need to ultimately decrease time and need to be. So I'm just giving you 1 minute video for this. If you're able to see this. So this application is actually in Foundry. So Foundry is producing 1,000 of cylinders per day for one global car maker. Now, if you see each cylinder, it's a single piece of electrical loop, which is where each process is now number of variables as being controlled. It can be temperature, it can be pressure, it can be a number of machine settings. So we can see this is, these changes in variables are causing this. It can complicate. It can give the distortion, crack, any defect can occur. It has to be used. But process start again and decrease. Ultimately, these all need to be, we are using sensor, this boundary measuring, and variable of cost, right, is the monitor and large basically we can have having a feeding data or feed this data into one.
नहीं चालू है बे चालू है
वो तो बोल रहे बोलोगे लेट है ना वाला चीज
I believe we have once again lost Dr. Ravimal. We are again trying to get in touch with him. We request all the participants to kindly be more patient. Looks like there is some technical challenge at his end. We'll get back to you shortly. We are trying to reach the guest once again, and our team will sort of get back. We have Dr. Agarwal once again with us.
Sorry, it's heavy rain is actually going on, and
we completely understand Dr. Agarwal.
So now actually, how much time I am having?
Actually, we have a few more minutes, right?
Means 5 minutes.
Yes.
So thank you. So I am just giving a conclusion in the terms of application which we have now seen. So I'm skipping this intelligent manufacturing slides. Evolution of manufacturing. Just directly going what actually industry perspective intelligent manufacturing. So first intelligent manufacturing perspective is manufacturing operations, which we are trying to convert into with the help of sensors. Then overall equipment effectiveness, then predictive maintenance. So if you wanted to do any kind of research, so as I told you, one of my paper is planning scheduling. So you can take either of this application and then you can start doing research in that area. So you can do in the process optimization, or you can do in quality monitoring, or you can do in particular these areas. So these are the enablers of smart manufacturing: Internet of Things, big data, augmented reality, CPS, cloud computing. So as I narrated and highlighted, how government is giving an award into different startups in these areas. So for giving a unique solution, so that we can have our manufacturing into intelligence. So I'm not giving this highlight, I'm just highlighting this. So that was the first thing, which Internet thing, where you can have your product, you can see your machine's health, inventory management. Second enabler is big data analytics, where you can use this to store or process this data, where Cassandra and Hadoop and Spark can be used. Another is virtual reality, augmented reality can be used in rapid prototyping for increasing safety or product design or maintenance. Cyber physical system for predicting maintenance, digital twin or information transparent environment. Cloud computing, as I given you the application in digital manufacturing, where you can see the centralized management and scalability of software is possible to cloud computing. Then additive manufacturing, there's material wastages and energy can be saved. Where traditional manufacturing, the 2000 kg billet is being there, where 20 is to 1 by 2 5, where you can only use 260 kg, where 2 is to 1 by 2 5. So where metal additive manufacturing is being used here. So you can see how 20 is to 1 or to we are using a less and less material in this. These are the highlights, or these are the projections which where companies are going. So they wanted to have less and less inventory. They wanted to have more and more in part reliability. So machine to machine communication, which can possible through agent-based manufacturing. If you are interested in do research, do it in agent-based manufacturing. I'm just skipping this traditional factory, smart factory, where traditional maintenance. So I have just wanted to give you the highlight how traditional factory has converted into smart factory with the help of these enablers. Where maintenance has 3 phases. One is reactive, preventive, and proactive maintenance, which can be possible through these enablers. So these are various intelligent shipping is there. Now data is being collected continuously through sensors. Where IoT for preserving refrigerator maintenance. Then food industries, health industry is one. So that was a case study. I will give only 1 minute highlight into this, where this total manufacturing industry or steel manufacturing industry is a process industry, where a large amount of iron, coal, recycled steel and raw material is there. So ultimately, with the help of intelligence or with the help of enablers, manufacturing process can be optimized, and where ultimately these steel industries are facing a problem of connectedness, data, quality, then quality traceability and manual operations, which are overcoming by this enablers, where you can actually have high reliability and safety requirement, and you can trace your product quality. So this is the solution which has been there for evaluation of customer requirement, how their requirement for establishing a new production process and production quality. So if you can see the information flow data for quality management and real-time process control. So this is the from business logic. You are having all type of control, process conditioning, process exception, quality status, quality availability can be possible. So this is you can have equipment status, quality inspection, quality standards. So basically now if you see the solutions so where you are having a large amount of data and these data are you can see these are the all kinds of steel industry equipment which are connected through IoT framework through digital twin you can have this application framework. So this data is going into and decision is being taken by these various algorithms. So in a nutshell I can say this. So one is IoT framework, another is operation framework, third is value stream. So basically this material, equipment, transport, storage all has connected through one particular technology called product digital twin where all equipment has now their virtual presence and through virtual presence you can process through quality, their process exception handling and their product quality testing. Where process specification production management system are being monitored. So I'm just concluding what we had started is we wanted to understand, we wanted to know our value, how our product, raw material is flowing from raw material to finished product. And then that is our cost of raw material is very important. Energy is very important, and then defect is incurring the cost. Overall equipment effectiveness is the very important aspect which need to be taken care. And now it is possible with the help of this various enabler, it is possible to visualize real-time data, compute, and give the optimization of various products. You can better manage the production, you can reduce this cost, and have the maximized value creation, which can be possible. And you have an informed decision what to make and how to make. So I'm just closing this. Invest in people, like as organizing committee of this conference doing, they are penetrating various advanced issues and organizing. Now, Malaysian government has started, like Industry 4, they have started an education program to give impetus of digital transformation, capability of intelligent manufacturing and digital transformation. So this, I should appreciate the organizer for having this kind of approach for this particular conference. And this is one of my journal via my editor. You can submit paper in this. They are blockchain technology for sustainable manufacturing based. This is the ESCI journal. There is another chapter, sustainable and industry 4 and supply chain. And submit this. Another is computer modeling, simulation, cyber physical system. Again, you can submit. Third is self-powered cyber physical system. You can submit. My research areas are this, and references are this. Thank you. I can say thanks for patiently listening to my talk, and sorry for inconvenience you have 2 times in this talk.
It's absolutely understandable, Dr. Agarwal, and we're pleased to have you here. Thank you so much for this short yet very insightful presentation that we had. At this point, I would once again thank you, and I also want to make an announcement that is quite exciting. So tomorrow itself, at the end of the session, after the tracks that is at the closing ceremony, we shall be announcing the best papers. So we request all the participants and the guests and the dignitaries and our live viewers also to join us tomorrow for the closing ceremony and to come to know about the best papers. Right. So with this, I would also declare that the inaugural function will be concluded with this talk now, and the respective participants are requested to join their respective tracks, and dignitaries are also expected to do that. Thank you so much. Thank you, Dr. Agarwal, for the closing note, and Thank you all the participants. With this, we declare the program to be officially, the inauguration program to be officially closed, and we open the track. Thank you. Dr. Agarwal, thank you for. So, may I request the participants to kindly leave this meeting now, and you may join your respective chats.